Welcome to the video on Chapter 5 Measurement, looking at Section 5.3 in your book on metric units. The objective today is going to be how to convert units within the metric system. So first, let's look at what a metric unit is. The metric unit that's a very basic unit for length is meters, and the meter is about equal to 1 yard. And so it's used when you are doing a number of things, and you'll see that meter is the basis, just like grams and liters are for many of the metric measurements, gram being weight, liters being volume. And so when we're looking at length and we're going to use meter as our base, then the metric system goes up and down on the difference of the units by powers of 10. So a centimeter is 1/100th of a meter, and a kilometer is 1,000 meters. So you either take division of a meter, so the unit that's about the size of a yard, and you either make it smaller, like a centimeter, or you make it larger, like a kilometer. And the metric units are actually really easy to work with because they're in units of 10. They're basically movement of a decimal place. So these are the most commonly used metric prefixes, so tera, giga, mega, kilo, centi, milli, micro, nano, and pico. And you'll notice that hecto and deci were left out, just because those aren't really used a whole lot in the technical field, and we're really concentrating in this class on math for the trades. But they are out there, and so hecto is a multiplier of 100 and deca is a multiplier of 10. And so you'll see that for metric length units and for weight units, that they use a paper clip as a standard of kind of comparison. And so a paper clip is about a centimeter wide, and the diameter of the paper clip is roughly about a millimeter. So if you're trying to get an idea of what some of those units look like, if you're unfamiliar with the metric system, then you grab a paper clip. And so metric to metric length conversions are fairly simple. Again, because it's by tens, you just can shift the decimal point. And so unity fractions, it makes it really a whole lot easier for unity fractions. You can see that the unity fraction down here is set up with centimeters and 100 centimeters here. So 1 meter equals 100 centimeters when you're trying to convert 348 centimeters to meters. And what's really easy is, since you're dividing by 100, what you're really doing is you're moving the decimal point over 2 places. Pretty easy, a lot easier using the metric system. To convert 7 centimeters to millimeters, you're going from something that is larger to something that is smaller, and so you're going to need more smaller things, so you'll have 70 millimeters in 7 centimeters. And again, because it's moving it over 1 decimal place, from centimeters or 100 to millimeters or 1,000, so the difference of 1 0. Metric weight and mass units aren't too different. Again, a gram is about the weight of a paperclip, and you use many of the same prefixes that we used before. And notice one thing that I want to point out, because this will be something that we are using in a later problem, that micrograms and milligrams, the designation, that little tilde m there versus a regular m, because we will be doing some conversion later with that. And so, as a matter of fact, if you want to convert 4,500 milligrams to grams, you use a conversion factor of a gram equals 1,000 milligrams. And so again, setting it up with your unity problem, 4,500 milligrams. We know that for every 1 gram, there's 1,000 milligrams. We take off of our units, the milligrams, and we multiply straight across and then divide by the 1,000 after multiplying straight across there, and we end up with 4.5 grams. Same thing with converting kilograms to milligrams, and we know that we're going to end up with a lot more milligrams than we are kilograms. Note that the kilograms is a very small number because it is 0.0062 kilograms, measuring units of 1,000 to milligrams. When we're looking at metric area, one of the things to note, just like all the other ones, is that when you are looking at area, you're multiplying your units times each other, so square, so you get a square unit, or meters squared. And when you're doing volume and capacity, you're multiplying 3 different sides together, and you're ending up with volume, or a cubed area. I believe it was 3.1.b in our video series that pointed that out. You can go back and look and get a better idea of what the different measurements are comparatively from the standard to the area, to the squared unit to the cubed unit. When we're looking at metric to volume conversions, then we can, this is again where we're looking at microliters, just like we were looking at micrometers before, and we also have milliliters, so make sure that you are keeping those separate, especially if you are looking, if you're in the medical industry, and notice that a cubic centimeter they also call a cc, and it's also a milliliter, so if you're drawing fluids, that might be something that you're pretty familiar with. So in this, looking to convert 0.24 liters to cubic centimeters, we're going to use a conversion factor, the unity fraction of 1,000 cubic centimeters over a liter, and multiplying that straight across, so we end up with 240 cubic centimeters. So let's go ahead and look at an example, and if you'd like, go ahead and stop the video and try this one on your own. Okay, we're going to set this up just like we set up other problems before, and we're going to take a look at what are the facts. The fact is it takes 60 milligrams of a medication 3 times a day, or that's what the patient takes. How many grams will the patient take in 4 days? So again, we really want to make sure that we're looking at what are the facts here. We're reading the problem, rereading the problem until we understand it. And so in this case, there's 60 milligrams of medicine, and the patient is taking it 3 times a day, and so that means that they're taking it they're doing 3 doses basically, and a dose is a unit, right? And so they're taking it 3 times in a day. And a day is certainly a unit also. Just because it's not millimeters and liters, these are still units of measurement. A year is a unit of measurement. And the patient's taking it in for 4 days. So times 4 days. Okay. Oh, and I'm sorry. The 60 milligrams is a singular dose. And so looking at this, we're going to say, okay, what do we have? We have, well, we have doses cancel and days cancel, which is going to leave milligrams, which is what we want down here. And because it said how many, well, actually it says how many grams, so we'll deal with that in a little bit then. And you go, okay, multiply straight across, 60 times 3 times 4. Is going to give us, let's see, 60 times 3 times 4 equals 720. 720, and that is actually milligrams because that's the unit that's over here. And so that's 720 milligrams, but it's asking for how many grams. So let's go ahead then and set the problem back up again, and we're going to say 720 milligrams is what unity fraction can we use that we end up with grams. So we know that for 1 gram it is 1,000 milligrams. And so if we now take and multiply straight across, we end up with 720 over 1,000. The milligrams cancels out. We move our decimal place over 3 times. Move our decimal place over 3 times because there's 3 zeros here, and it's 1, 2, 3, and we end up with 0.72 grams. And for the next problem, we're looking at a problem that I really encourage you to read the problem, go back and reread it, read it until you understand it. What are they looking for? What are the facts? And what do we know about this problem that we can set up a problem? I'm going to give you a little bit of a hint, and that is that it has to do with the last chapter, and that it starts with a ratio and proportion. So go ahead and pause the video, see if you can get started on this, and then we'll dive in. Okay, so let's go ahead and see what it is that the problem's looking for. It says a very active adult who wishes to maintain her weight is on a diet of 2,300 calories per day. A nutritionist advises her to limit her intake of saturated fat to no more than 7% of her total calories. Fat contains 9 calories per gram. What are the maximum number of grams of fat per day she should consume? So a few things that we know for facts. One of them is it doesn't matter what weight she's maintaining, because that's just a weight that she's going to have. We do know that that the person can only get 7% of her total calories from fat. So we know then that 7 out of 100 of the calories can be fat. And then so we go, okay, well then the equivalent for how many calories that she's getting, so it's 7 out of total calories, and so these are calories down here. Total calories are 2,300 calories, but we don't know how many of those calories can be fat calories. So we'll go ahead and look at this and say, all right, well, because we have a ratio proportion, I'm hoping that you guys are seeing this. What we can do is and the only time we can do it, cross multiply and divide, and so we will end up with 2,300 times 7. And so 16,100 equals 100F. And so with this, then we're going to go ahead and what we do to one side, we have to do to the other. If this doesn't look familiar, then please make sure to go back and watch the video from last week. So those will cancel out. 100 16,100 divided by 100, well, there's 2 zeros there, there's 2 zeros there, so we move the zeros over, or the decimal place over, and we get that F, or fat, equals 161 calories in saturated fat that she can have. All right, great. So does that answer the question? Let's go back and look at it again. And it's asking for what are the maximum number of grams of fat. Okay, all right. Well, see what we've got here. We've got 9 calories. Fat has 9 calories per gram. That's a great thing. Okay, so then what we can do is let's set the problem back up again. I'm trying to figure out a way to be able to get my screen a little bit more room there. Okay. So now we'll go ahead and bring down the known information that we have. So she can consume 161 calories per day. And we know that there are, in 1 gram of fat, it contains 9 calories. So now let's just go ahead and we can cancel out our units here, and we will run through the numbers. And so get the calculator. And so we have 161 divided by 9 equals 17.888888. All right, but we also know that we have significant values being in the ones place. So rather than 17.88888, we're going to say that that is 17, and they're looking for grams of fat per day. Grams, which is what we're left, grams per day. All right, great. So next we're going to look at an example, and this comes from maybe the environmental science field. When they're measuring parts per million, you can see that it's measured in milligrams per liter, and that's what a part per million is. And when these very small amounts are measured, they're reported in micrograms per liter. So this is the problem I wanted to point out to you, that in this conversion and on your homework, what you might see is milligrams and micrograms in the same problem. So make sure that when you set that up, that you do the right unit of conversion for the liquid volume down here. Okay. All right. So this will be one for our allied health students. So go ahead, and we're going to read the problem. In working with intravenous IV infusion, nurses must often measure flow rates in drops or sometimes micro drops per minute, while the solution itself is measured in milliliters. So it comes in a bag and it's measured in milliliters or liters. And suppose that you have a 750 milliliter IV that must be given to a patient over a period of 6 hours. The nurse must set the flow rate in drops per minute, and the drop factor for the solution is 15 drops per milliliter. The nurse must perform the following conversion. So let's look and see. And so they're asking you for what are the drops per minute that this comes out with. So go ahead and pause the video. This is almost the end, and so hopefully you've got a good grasp and you can take this problem on. And I'll give you a pause and we'll come back in a minute. Okay, so let's go ahead and set this problem up. Of course, what we want to do is, after we've read it and reread it and reread it again, we want to figure out, what do we know? Well, we know that the drop factor for this solution is 15 drops per milliliter. And so we're going to say, all right, we know that it's 15 drops per milliliter. And then we know that there has to be 750 milliliter dose given over a period of 6 hours. And so that should clue in that that's a fraction. So that's a time per hour. It's an amount per hour. So it's a rate. So 750 milliliters per every 6 hours. And so notice we're setting up, we've got milliliters and milliliters going, so we're going good here. We need to figure out now, because we can go ahead and let's just do this as we go along. We can cancel out milliliters, and we've got drops per hours on here, but the problem is asking for drops per minute. And so let's see, we can convert then. We know that there in 1 hour there's 60 minutes. So now we can cancel the hours out and then go ahead, and we've got drops per minute is a units. That's what we're actually looking for. So let's go ahead then and multiply across both of these, and we're going to end up with this equaling, let's see, 15 times 750. And that's 11,250. Over 6 hours times 60, so that's 360. So let's go ahead and 11,250 divided by 360, and that is 31.25. And notice that there isn't a 0.25 anywhere on here, and so we're not going to measure drops with a decimal, and so we will round down, and we end up with 31 drops per minute. So the last slide on here is a conversion factor for metric system, much like the last video ended with a conversion for standard. So hopefully you can take this and use this for your homework.